Turn links into ranking PageRank is the simplest graph trick that still works everywhere. By the end, you will see how link structure creates a stable important score and how to turn that into a small recommender for users. I'm Professor Pi, teaching AI foundations with simple Python. PageRank answers a concrete problem. You have items that link or follow each other, and you want a single number that says which items matter most. People reach for PageRank when plain counts fail, because links carry qualitative signals about authority and relevance. It is fast on small graphs and still useful at medium scale as a descriptive baseline. Intuitively, PageRank simulates a random surfer who follows links but occasionally jumps to a random node. Nodes that collect more of that wandering probability are more central. Imagine a tiny web of 5 pages. A tightly linked trio will keep a lot of the surfer probability. And that reality is what PageRank quantifies. We will build a tiny directed graph. Inspect basic PageRank. Test sensitivity to the damping factor. Create a readable leaderboard. Add weighted edges to encode interaction strength. And finally, bias teleportation to make a per-user recommendation. Now we'll build a tiny graph and compute PageRank. This snippet builds a small directed graph and computes PageRank using NetworkX. The variable edges lists who points to whom, capturing link structure as pairs. The object G is a digraph that stores the network, so NetworkX PageRank can operate on it. The function NetworkX PageRank returns a dictionary PR, mapping each node to its stationary probability score. The variable top selects the node with the highest score using Python's max with pr.get. The alpha of 0.85 is the common damping setting that balances link following and teleporting. The printed top node and its score show which page is most central by link authority. Next, we will test how the ranking reacts when the surfer behaves more randomly. This example reruns NetworkX PageRank with a lower damping factor to test sensitivity. The variable alpha sets how often the random surfer follows links versus teleporting. The function NetworkX PageRank computes a new score dictionary PR low under this setting. The variable T2 again picks the highest scoring node, showing whether leadership changes when users explore more randomly. Lowering alpha pushes scores toward uniformity and can reduce the dominance of tightly connected hubs. Increasing alpha emphasizes link structure more strongly, often boosting nodes with many high-quality inbound links. The printed top and score reveal how robust your ranking is to surfer behavior choices. Then, we will turn raw scores into a neat ranked list you can show to users. This code turns raw PageRank scores into a clean, ordered leaderboard. The variable K sets how many results to surface. The sorting expression orders nodes by descending score, then by name to break ties reproducibly. The list pairs collects each top node with its rounded score for readable display. Using the existing PR dictionary from NetworkX PageRank keeps computation minimal and lets you focus on selection logic. This pattern mirrors how you pick top documents or influencers for downstream use. The printed ranked list is your first cut of winners, ready for a UI or API. After that, we will model stronger and weaker connections by weighting edges. This snippet injects interaction strength into the graph and reruns NetworkX PageRank with weights. The dictionary-like access that sets the weight on the edge from A to B determines how much of A's influence flows to B relative to its other links. The function NetworkX PageRank with the weight attribute uses these values to proportionally split outbound probability. The variable PRW holds the new weighted scores, and TW identifies the leading node under this emphasis. Heavier weights boost recipients when their sources already carry authority, shifting the ranking meaningfully. Increasing a weight on a path concentrates flow there. Decreasing it spreads flow back to other neighbors. The printed top and score confirm how weighting changes the network's winners. Finally, we will make PageRank personal, so it can recommend a next follow for a user. This code turns PageRank into a recommender by biasing scores toward a specific user in NetworkX. The dictionary purse concentrates teleportation on A, making NetworkX PageRank favor paths relevant to A. The variable PPR is personalized, and using the weight attribute keeps the influence strengths from earlier. The set canned filters out A, and everyone A already follows, leaving only potential new follows. The expression that picks the maximum candidate chooses the best unseen candidate by personalized importance. Increasing alpha in this setting emphasizes multi-hop network evidence. Decreasing alpha leans more on the direct personalization. The printed recommendation and score show a concrete actionable next follow for A. Now imagine how this small toy maps to a real system. Replace the tiny node names with product IDs or user IDs. Replace manual edge weights with observed interaction counts or recent engagement scores. Run personalized PageRank for a handful of active users to generate candidate lists, and then validate those candidates with click or conversion metrics. At larger scale, you move the core logic into a graph database or a batch job that materializes personalized scores for active users only. Even there, the same knobs work. Damping controls how much multi-step exposure matters, and edge weights let you encode recency or trust. Recap in 3 crisp points. What it is: PageRank is a link-based scoring method that measures how probability flows through a directed network. When to use it: use it for ranking items when link structure or follow patterns carry meaningful signals, or as a simple graph-based recommender. One caveat: PageRank captures global connectivity and can underweight fresh or niche items unless you add weights or personalization. Next step: tune the damping factor alpha while measuring ranking stability and recommendation quality on a larger sample of users. If AI Foundations in Python help, subscribe and watch the AI Foundations videos.